Okay, in this video lecture, I am going to cover oxidation numbers, which is section 7.2, and I'm going to go through the rules for assigning oxidation numbers, and then talk a little bit about the stock system, and then go through a lot of examples for oxidation numbers. So oxidation numbers can also be called oxidation states, and basically it's the number of electrons that can be added or removed from an atom in a combined state so that it can be converted or bond with another element or compound. So oxidation states on the periodic table, I have them written on top. It's the +1, the +2, and then you skip the D block, and it's the +3, the 4, -3, -2, -1. Those are technically oxidation numbers or oxidation states. And when you assign those oxidation numbers or states, basically the shared electron is going to assume to belong to the atom that has the higher electronegative value. So remember, fluorine has our highest. The trend for electronegativity is it increases across the period and decreases as you go down a group. So here are the rules. There's quite a few rules. Some of them are pretty self-explanatory, or just like, oh yeah, that just makes sense. So the first rule is that elements in a pure, if I could read here, atoms in a pure element have an oxidation number of 0. So that means if you have one element and that element is either by itself or it's bonded to itself, the oxidation number is 0. So your answer would be 0. So I have examples: sodium, O2, that would be 0. P4, that would be 0. Sulfur, 8, that would be 0. Second rule: the more electronegative element in a binary compound, so a compound that has two elements, is assigned a negative number equal to the charge it would have as an anion. The less electronegative element is assigned a number equal to the positive charge. That would be the cation. Basically, charges, we're looking to balance our charges, okay? But there is an exception to that rule. Third rule: fluorine has an oxidation number of -1 in all of its compounds because it has the highest electronegativity value of 4.0. Oxygen, okay, rule number 4, has an oxidation number of -2 except when it's in peroxides, okay? So here, a peroxide is, we'll just say this is X. So if it's X2O2, that is a peroxide. Okay, so it could be H2O2, could be Na2O2, but it's 2 and 2. That's a peroxide. So now the oxidation number of oxygen is -1. And the second exception is when it's bound with fluorine. So fluorine, like OF2, has a -1 charge, right? But I have two of them for a -2, so then this has to be +2. So those are the exceptions for oxygen. Rule number 5 deals with hydrogen. It has an oxidation state of +1 in all compounds containing elements that are more electronegative than it. And if it's with a metal, then it's going to be a -1 because metals have the positive charge. Rule 6, the algebraic sum of the oxidation numbers of all atoms in a neutral compound is equal to 0, except, which leads me to rule number 7, if it's polyatomic. Polyatomic ions, I think found on page 220 in your books, have various charges like +1, -1, +2, +3. Those are like your carbonates or your permanganates or hydroxide, whatever. Okay, so those are polyatomic ions, and they have charges. So then you are shooting for an algebraic sum of that charge. And if you don't understand what I'm saying, hopefully my examples coming up here shortly will explain rule number 7. 8, although rules 1 through 7 apply to covalently bonded atoms, oxidation numbers can be applied to atoms in ionic compounds. So like you can apply these rules to ionic compounds, and you use the crisscross rule to balance out those charges, okay? So here are some sample problems that you have in your notes, okay? So I did my best to color code. This is how I would do this problem. So if I have CF4, I start by placing the known oxidation numbers above the appropriate elements. And right away I see fluorine. And fluorine is always -1. Okay? So fluorine is -1. But I have 4 fluorines. So -1 times 4 is -4. So your second step is multiply the known oxidation numbers by the appropriate number of atoms and place the totals underneath the corresponding elements. Third step, the compound is molecular, so the sum of the oxidation numbers must equal 0. So if fluorine is -4, this half is -4, well, that means that this half has to equal +4, so it can cancel out to 0. Now, thank you. This is where it gets confusing. So I multiplied -1 times 4 to get to -4. But to go back up to figure out what the charge of carbon is, because carbon, yes, you always think it's +4, but it can have some other charges. You divide. So this half has to be +4. I have 1 carbon, so +4 divided by 1 means that this carbon has a +4 charge. So then your answer would be +4, -1. Or you can say carbon equals +4, fluorine equals -1. But if you just give me the numbers with the commas spaced in them, you have to write them in the correct order that are listed in the compound. So like if you wrote fluorine's oxidative number first, -1 comma +4, I will mark it wrong. Okay, it has to be in this order, the order of the elements that appear in that compound. Okay, HNO3. Start by placing known oxidative numbers above the appropriate elements. Right away, I see oxygen. Okay, it's not a peroxide, 2 and 2. It's not bonded with fluorine. So the oxidative value for O is -2. I also see hydrogen. Hydrogen, it's not bonded to a metal here, so that means it's going to be +1. Okay, so I got rules 4 and 5. That's how I got these blue numbers. Second step, multiply the known oxidative numbers by the appropriate number of atoms. So I have 1 hydrogen. 1 times 1 is +1. -2 or -2 times 3 is -6. Now this has to equal 0. I'm going to get a pen here. This has to equal 0. Okay? So a slash to show that it's 0. So what does the value of n have to be? If I have a -6 and a +1, right? So that means that n has to be +5. Okay, +5, which this is new because, when you look at the periodic table and you find n, it's usually -3. But nitrogen does have some other oxidative values, and I'll show you a table here shortly on that. Okay, so +1 +5, that is my overall, +6 -6 to get 0. So that means 5 divided by 1 is +5. So my answer would be +1 comma +5 comma -2. Or you can say H equals +1, N equals +5, O equals -2. PO4 -3. Okay, start by placing known oxidative numbers. All right, I see oxygen. It's not a peroxide, and it's not with fluorine, so it's -2. -2 times 4 for the second step here is -8. So this is where we need to take a look at the charge. Are we going to 0 or are we going to a charge? We need to get to a -3. Okay, so what does P have to be in order for it to be -3? So this is kind of like an X, right? X minus 8 equals -3. So if I add 8 here, and I add 8 here, what do you get? Okay, that's really bad. Wow. You get a +5, right? So that means that this half, I'll slide this out of the way, has to be +5. And I have 1 phosphorus, so 5 divided by 1 is +5. So my answer would be P equals +5, comma, O equals -2, or +5, comma, -2. So it has to, or equal, or instead of going to 0, we're equaling it to the charge of that polyatomic. Now, many nonmetals do have multiple oxidation numbers. Like when we were doing ionic bonds or compounds, And I was like, yeah, if you're in the D block, you need Roman numerals because it can have various charges. Well, some non-metals, actually many of them, have multiple oxidative numbers too. Like carbon can be, instead of just +4, it could be -4, it could be +2. Take a look at nitrogen. -3, +1, +2, +3, +4, +5. You know, so yeah, chlorine's got a few too. So when we use these oxidative numbers, basically we can use the stock system to rename our covalent compounds. Okay, so 7.1 was all about naming covalent compounds, and that was the prefix system. You know, PCl3 is phosphorus trichloride. PCl5 is phosphorus pentachloride. You write the first name as is, and there's no prefix from one, but if you had multiple, then you would. And then you change the end of the IDE and you use the prefix. Like down here, N2O. Well, you write nitrogen, but I have more than one nitrogen, so there's 2 of them. The prefix for 2 is di. Dinitrogen. I have 1 oxygen, so the prefix for 1 is mono. I changed the ending of oxygen to oxide, so it's dinitrogen monoxide. So they're just saying, hey, you know what? Now that we have these multiple oxidative states, we can use Roman numerals to show those multiple oxidative number states. So phosphorus trichloride, well, instead of saying trichloride, you can say phosphorus Roman numeral 3 chloride, because phosphorus here has a +3 charge. Or phosphorus 5 chloride. So basically, the stock system is treating covalent compounds as ionic. All right, so here are the sample problems. I wrote the steps down here. These are the elements that have multiple oxidative numbers: carbon, nitrogen, phosphorus, sulfur, chlorine, boron, and iodine. Wait, I'm going to double check that. Yep, okay. So, S2O3, IC oxygen. It's not a peroxide. It's not bonded to fluorine, so that means it's got a -2 charge. Second step, multiply the known oxidative numbers by the number of atoms you have. -2 times 3 is a -6. So that means S2 has to equal a total of +6 to get to 0, right? To balance these out, to cancel each other out. But I have 2 sulfurs, so 6 divided by 2 is +3. So your answer is +3, -2. Cl2O. All right, I see oxygen. It's not a peroxide, it's not bonded to fluorine, so it means it's -2. -2 times 1 is -2. So that means Cl2 has to have a +2 charge. But I have 2 chlorines, so I got to divide to get back up here. 2 divided by 2 is +1. So your answer would be +1, -2, or Cl equals +1, O equals -2. P2O5. I see oxygen again. It's not a peroxide. It's not bonded to fluorine, so -2 times 5, -10. So that means this P2 also has to equal +10. But what's the charge of just 1 phosphorus? Well, I take 10 divided by 2 plus 5. So your answer is +5, -2. KClO3. All right. Oxygen, it's not a peroxide. It's not bonded to fluorine, so it's -2. -2 times 3 is a -6. Potassium is not an element that has multiple oxidative states, so I can get the oxidative state from potassium. It is found in group 1, and that is +1. So 1 times 1 is, +1. But that means KCl has to equal an overall -6. So if potassium here is +1, what does chlorine have to be? Okay, so like this, it has to equal +6, 6 minus 1, +5. Okay, and chlorine is one where it can be +5. Go to the previous table. Look, it can be +5. I don't know if it's necessary for me to click through all of that. Okay. Cl4, 2. All right, so you see oxygen. You're like, all right, it's not a peroxide, it's not fluorine. It's -2. -2 times 4 is -8. But then you see this 2 here. That means you got to take it times 2 again. So -2 times 4 is -8. Times 2 is -16. Calcium is not listed down here. It's found in group 2. That means it's got a positive 2. Okay, so calcium and chlorine together have to be plus 16. So, how many chlorines do I have here? 2. This 2 goes to everything inside, right? So I have 2 chlorines. Well, this plus 2, I only have 1. So if I subtract 2, now I have a plus 14. And then 14 divided by 2 is 7. So chlorine here has a plus 7. So your answer would be plus 2, comma, plus 7, comma, minus 2. CO3, negative 2. This is a polyatomic. So I see oxygen. It's not a peroxide, it's not bonded to fluorines, minus 2. Minus 2 times 3 is negative 6. Now, we are not balancing it to 0. It has a charge. We are balancing it to minus 2. Okay? So that means carbon over here has to be, plus 4. Okay? Because I need to get to minus 2. So it's like x minus 6 equals minus 2. Well, if I add 6 over here, I end up with a positive 4. So this carbon is 4. 4 divided by 1 is plus 4. So your answer is plus 4, comma, minus 2. BR2, rule number 1. If you just see one element or an element bonded to itself, the oxidation state is 0. Na2SO4. So you see oxygen. Oxygen, it's not a peroxide, it's not bonded to fluorine. Oh yeah, that's the reason I don't have, for some reason I don't have my numbers on this one. So it's 2. Minus 2, sorry. Minus 2. Minus 2 times 4 is minus 8. Sodium is one that just has one oxidative state, and in that case it's plus 1. Okay, but I have 2 of them for a plus 2, which leaves me with sulfur. So, what does sulfur have to be to get to 0? 2 plus x minus 8 equals 0. Well, that means sulfur here has to be plus 6, right? So your answer would be plus 1, comma, plus 6, comma, minus 2. NH4 2S. Okay, I don't see oxygen, and you might be freaking out, but hydrogen is a rule, and you can see it's not bonded to a metal, so its oxidative state is plus 1. But I have 4 of them, so it's plus 4, but that little 2 on the outside, I gotta multiply that. So 2 times 4 is plus 8. So, plus 8. Okay, now, nitrogen and sulfur, they are ones that can have multiple, okay? But in covalent compounds and ionic compounds, because covalents, they can also be treated, or they can be named like ionic, your cations are first, okay? You'll notice that your cations are always in the front, and your anions are in the back. So if I take a look at this table, okay, I had nitrogen. It's got a minus 3 value, but it can be pluses, so it's most likely going to have a positive value. If you find sulfur, it can be positive, but it can be negative, and sulfur's at the end. So that means that sulfur has to have a negative charge, and sulfur only has one negative charge value, and that's going to be minus 2. So redo this here. So that means sulfur is going to be minus 2. Okay? So minus 2. So that means what does the charge on nitrogen have to be in order for all of this to balance out? That's supposed to be an equal sign. Oh, gosh. Okay, wow. Epically messed up on my 0 there. So, x plus 8 minus 2, add 2, subtract. That means it's got to be... why can't I do math in my head? Minus 2. Minus 6. and then it balances out. That one was tricky. You won't find those on your homework assignment. All right, the last one, sodium peroxide. This is a peroxide because it's 2 and 2, and it's with an O. So our rules with peroxides is that now O has a -1 charge. So -1 times 2 is -2. That means that this half has to be +2. And then I have 2 of them, so 2 divided by 2 is +1. Okay, so the assignment is actually going to be in your book. Okay. Let me grab my book here. Page 229. Question 1. Okay, and you do A through I. That's it.